You've heard all the hype around context graphs, and you're probably wondering, what are they? Well, you're looking at one. We built a context graph based on data from London area pubs, restaurants, event spaces, and here you can see how all of those are connected to each other and interrelated. But you might be thinking, wait a minute, I thought context graphs were all about things like decision traces and explainability. Well, there's that too. We can also show the explainability when we ask a simple question. If we look at this data set and we ask, where can I drink craft beer? What pub can I drink craft beer? And now we can actually see the graph, the subgraph, and also the concepts, the grounding concepts, which actual relationships in the graph are being pulled to generate the response and being able to go through this sourcing information. So here we see that we've asked a very specific question that limited the data to return one simple answer. But you might think, well, why did we get this answer? And again, if we look through at the explainability, we can go through and see the actual source data, where this came from. Now, what's really interesting is when we can see this answer, what if we ask this question in a slightly different way? What instead, the first time we asked specifically, where can I drink craft beer in a pub? So now that we've broadened the question, we still get the same answer. But if we look in the response, we see that the grounding has actually broadened the concepts that were available to us. So that now, even though we've gotten the same response, just by asking the question in a slightly different semantic way, we see how many different concepts have been engaged. And while that may not immediately seem like a big deal, this is exactly why we started building TrustGraph all these years ago. It seems like so many years ago, doesn't it? And here I am. I am Daniel. You probably know me at this point. I am the co-founder, co-creator of TrustGraph. And today I have with you a rare appearance by the other co-creator of TrustGraph, Mark Adams. And wouldn't you agree, Mark?
With you. Yeah.
Wouldn't you agree, though, that when we started this journey, this is exactly the sorts of things that we cared about?
Yeah, absolutely. So this is something we've been building up to for quite a long period of time, as we've put the fabric in place, the graph, and then the ontology support, and then finally the explainability. It's great to be able to show this off now. So now we've got it working end to end. But the full trace from, all the concepts, how the query was answered, all the processing that made that happen, and then the trace back to the source documents, so you can check for yourself. Does the answer make sense? Where did the information come from? Is it out of date? It's great to be able to demonstrate this to you today.
I get a lot of questions, though, about graphs themselves. Should we perhaps start kind of talking about just the graph building process, at the beginning point of what we're talking about when we're talking about graphs and what that graph building process looks like?
Yeah, I think, should we show people the workbench? This is how we start off by taking a bunch of plain text documents or PDF documents into the system. I can start by taking one of these documents here. Let's do the Flatiron, Square, and Borough document. I'm going to select to put that through a blueprint, and then that goes in for processing with TrustGraph. Document there starts processing now.
And again, the TrustGraph Workbench is a tool that is meant to just be able to test really the capabilities and be able to understand how all the capabilities work together. What we're showing you in the other tab is more like an actual app that you would build on top of TrustGraph.
So if we feed a search term in, the first thing that the system does when you feed in a document is start to map out the concepts inside of that document and build a vector store that maps those concepts through to a graph. So the first thing we see is when I do a search for Bermondsey, there's various terms that are close matched to that semantically. If I click on, say, Bermondsey here, you can start to see some of the fabric. We can see that three-dimensionally. This is some of the fabric inside of the graph. You can see the relationships between things. So we found Bermondsey. This represents Bermondsey, the tube station, the metro station, which is on a metro line called the Jubilee line. And we can see, let's have a look. We can see that the Jubilee line has a type, which is transport line. I think we'll see that Bermondsey, we can find out what type that is. Oh, it's already got the type. There we go. It's type transport stop. we can sort of see what else can we find out in here. Let's go and search for some pubs. Great. There we go. So this has got a lot more going on in this section of the graph. We can see there's Crate Brewery at the center of that. We can see its price level is budget to mid-range. Actually, since that is a node, we can also find out if there are any other pubs that are in that range. We've got mid is a level. There we go. So we can start to see, you can start to see how we've built up this graph. This graph explorer is not intended to be an end user facility. Navigating graphs by viewing them is probably going to send everybody over the edge insane. But this gives you an idea about how the graph is structured.
And that's something that we've actually seen just recently, that LLMs, like coding agents and coding tools, have actually gotten very good at building graph visualizations. So, that's something that, as you see in the app, that the demo app that we created, we were able to create a very sophisticated graph visualization, basically, from scratch, which is as opposed to using kind of a more traditional off-the-shelf graph visualization tool, which we were doing in the workbench.
That's right. So TrustGraph is a system that we've built for builders to use to build systems. So over time, we're going to be able to, we offer TypeScript libraries for being able to build UX with that some of the code assistants already know how to use, but we'll take this further and build more components for people to be able to build UX like this with.
So is this is more of a flat graph that you were showing us on the other screen, wasn't it? Or is this one built with an ontology?
So this one is built with an ontology, but yeah, and I think it's interesting to compare with some of the earlier work we did. We've explored how effective it is to build ontologies over time, and I think ontologies have turned out to be very effective for AI graph RAG algorithms. But we started off building without ontologies, so just using language models to determine, just to learn the concepts free form without having to be locked into an ontology. And it's interesting to be able to compare. We've got multiple techniques that work well for different domains.
Right. So again, that was actually the initial genesis of TrustGraph, was using semantic similarity search as a way to generate subgraphs with a very, very flat graph structure, just basically building a graph as a just raw triple store, so that you just have basically just a list of triples, and then those triples have connections. They may share nodes in common, and using semantic similarity to basically find a starting point, and then you're able to extract subgraph. But then we found that using ontologies actually increased the precision and accuracy of being able to retrieve this kind of information, from the graph. So I think a lot of people are also wondering, what really is an ontology? They may have heard about that term, they may have seen talks about it, but what does that actually mean? What is an ontology when you actually see it in front of you?
So that's a great question. So I think people might be familiar with how databases might have schemas, or if you're used to code, producing code as a programmer, you'll be aware that information has different types of classes, structures around how that's organized. And we use an ontology is a mechanism for structuring, I guess, concepts within language. It's quite similar to database schema, but it's very good at capturing the underlying meaning of information as well. So in our ontology, for this particular demo example, we've got information related to venues in a city. So we've got a class of information, which is the atmosphere. You can see we've got community spirit and cozy, creative. You've got cities. You've got neighborhoods within a city, events that might happen at an event. And so the ontology structures information in terms of, these structures, these types, classes, and allows, our ontology processing allows the language model to take information and determine that it is a match for a certain type, a class, the structures, the relationships between data. And so it very strongly steers the language model towards how information is structured. So the knowledge graph we've taken control of, we said we will only accept certain relationships, there will only be certain classes of information. It creates a knowledge graph with a lot of precision compared to the free form, the schema free. Without an ontology, the language model is having to determine the relationships. And, sometimes there are relationships that are the same thing with different names. With an ontology, we force it into a much more precise structure.
Don't we have to talk a little bit, though, about when we talk about ontologies, don't we have to back up a little bit and talk a little bit about graphs themselves and property graphs versus the semantic web? Because there are some slight differences in how you can structure graphs, how you query graphs. And if we think about, mathematically what a graph is, or from a computer science perspective, that tends to be one way of looking at the problem from an information theory perspective. But when we talk about the mechanics of how we actually build these systems and work with them, most people, when they think of graphs, they're familiar with the Neo4js, and those, very much firmly fall into the labeled property graph category. But when we talk about ontologies, that kind of steers us into some different ecosystems of implementations.
Yeah, that's right. So for TrustGraph, we've been very much guided by the RDF ecosystem and that style of representing information. One thing particularly of interest there, I guess, that was of interest to us is how you can represent multiple different languages quite easily within a graph. But the other thing is there's other aspects. For instance, reification of information is going to be important. So the ability to associate information between edges and other nodes of the graph is going to be a very powerful way for rarefying information, or that is providing information about information to say, to describe the temporal nature of information, the accuracy, and as you've seen in this demo, you can see we've associated information with sources and tracing back from edges in the graph through to the sources. Where did that information come from? And so this is very important for us as we build explainable graphs. We are going to be using some of these. The infrastructure of the graph is particularly important for making that work.
Well, some people are probably thinking, though, why can't you or can you use this kind of approach with property graphs?
People have had battles over disagreements between people, but knowledge graphs versus property graphs. All we're trying to do here is to make something that works. I think it's possible to probably get both of those types of graph to work to do the kind of thing we're trying to do here.
Again, mechanically, because again, this is kind of what, people are very familiar with that style of graph. And, why would doing it this way provide advantages?
So the reason it's structured the way is that we have to think about the whole stack. We have to think about how to make the information useful. We have to make sure that it supports the APIs that we're building, and we have to make sure that it works at large scale. So the fabric of the graph that we've created here has been structured to be able to do all of those things. In the world of language models working with AI, to answer questions like this, there are particular retrieval patterns that are commonly used that may not be present with other graph systems, and other graph systems may support retrieval patterns that we probably don't care about for introducing AI to knowledge graphs. And so we've particularly tuned this stack to be able to explainably answer questions in the realm of AI.
Well, I think that's an important point, is that in a lot of ways we're using knowledge graphs or context graphs, that we're now seeing to be the term that people want to use, much more like how semantic networks were proposed going all the way back 60 years ago. If we look at how knowledge graphs have been used a lot in the last 20 years, some of the most common use cases are things like fraud detection, AML, KYC in the financial sector, that's know your customer, and anti-money laundering, a lot of cybersecurity detection where you have a lot of events that are described by some sort of string or metadata, and you're trying to find, pattern matching in that, anomaly detection, but not so much the actual semantics of language and in relationships in language. So I think that's kind of one of the big distinctions, is that this is a bit of an old use case becoming new again with the need for being able to ground LLMs in more richer semantic structures.
That's a really great point. I think you think about semantic web and how it sort of reinforced the need for a lot of this graph technology. And I think the feeling is that graphs never really achieved the success that they could potentially have achieved. And, the world has been kind of ruled by tabular information and structured databases. And really the most complex part of this is like building graphs is actually quite hard. And so it's much easier to force things into a tabular structure. But I think, language models have just suddenly caused this technology to be just so much more relevant again. And I think it's great to be able to combine these technologies, and you can kind of see, hopefully in this demo, the power of the graph in the world of language models, explainability, AI. It's a very rich technology. It's got a lot of power behind it.
This was a lot of what I talked about, with Vicky Froen in our recent discussion about deep learning versus neuro-symbolic AI, and how this very much using graphs and graph structures is what was neuro-symbolic, or what is the neuro-symbolic AI approach. And again, that the deep learning approach was more that you throw data at these neural nets. If you throw enough data and enough compute, that we would be able to somewhat, I would say, magically be able to get to ground truth. That was kind of the promise. And the neurosymbolic AI thinkers were always of the mindset that you would need richer semantic structures because of all the disambiguation in language. We started out this demo by showing that, just even though we got the same answer when we asked, let's see, what did we ask? We asked, what's a pub where you can get craft beer? And then we just said, where can I drink craft beer? Even though we got the same answer, the process of going through that was very, very different. Yeah, let's look at that again. So where can I drink craft beer? So look at all the concepts that we went through. These are all the places where we might drink beer. Bars, bars, beer cafes, events. Like you could have an event. A craft beer festival, a beer garden. So many different so many different concepts that could potentially arise from this. Because, okay, see, at this point, and we're using Mistral Small 4 for this demo. So we haven't done a lot of testing with Mistral Small 4. So we're kind of doing some testing in public right here to see the capabilities of it. So we can see it gets this here. This is actually more along the lines of what people were saying with decision traces, and here we're able to see how the information in the graph actually contributed to the response with that source provenance. But can we I'd love to go back and ask the question a different way again and see, because again, we can really see all the different concepts and the data in the graph that we went through to get to this answer, because we asked in a very general way. But what happens when we ask it more specifically? So I think we would ask, what did we ask last time? Like, what pub? I think, yeah. Can you recommend a pub which serves craft beer? And see, we can see how much this is actually limited the context that we're extracting from the graph, because we're only looking at pubs and craft beer now. So just that, it seems like a very, very similar question, but semantically it's not. We placed a filter just by adding that simple addition of, what's a pub I can drink craft beer. For instance, like if I was in London with Mark and I said, hey, where can we drink craft beer? To me, in my mind, that's the same thing as asking, well, what's a pub we can drink craft beer in? Because, that's kind of assumed, right? We would drink craft beer in a pub. But semantically and in information theory and in language, they are not the same. And they don't produce the same results. And here we now finally, with TrustGraph 2, we're providing everyone, because TrustGraph is open source and always will be open source, the tools to now actually see that those two questions are very much not the same and lead us down a completely different path on how we would get a response. And not only being able to see it, but to see it visually and being able to trace back all of the source data. So This is something very new in TrustGraph 2. This is really the promise of context graph, not just the graph of initial grounding context, but then being able to do this traceability, this source provenance, this explainability for being able to understand how two seemingly similar questions, in my mind, they are the same question, are not the same question. So that's a lot I know to unpack. So where do we start, Mark, by explaining all of the things that we are launching with TrustGraph 2 and realizing the potential of context graphs and where we're going with it?
And really, the headline feature of TrustGraph 2 is explainability. So, on making sure that that as documents are ingested into the system, the full source graph, there's a knowledge graph which tracks all of the source components through to the chunks, through to the information that is extracted out of those documents. So source provenance, I think you can call it, explains is part of the explainability AI solution, explaining where we got information from, taking it all the way back to the document. So you can see here on the screen, that particular fact there, we know it came from that particular chunk, and you can say, well, we'll be able to using the APIs, you could find out where did that document come from, when was it ingested, do we trust it, what's the source? And so the other part of it is the explainability at retrieval time. So here you can see on the right-hand side, we've gone from question through to how the question was grounded. These are the concepts that using a language model, we worked out those concepts are relevant in answering that question, through to the nodes in the graph that are related to those concepts, through to the edges of the graph, and how those represent facts or information that is going to be consumed into the final step, the synthesis step, where we go ahead and answer the question. And so because we've got the full trace through the retrieval side, you can see, okay, well, I know how, I've got a very good understanding about how the answer was constructed, which sources were used. And now what we've got here on the screen is a demo. It is designed to show everybody how this works. I think this might not be sort of necessarily end user consumable, so you can produce much more tailored responses that show, you could probably do quite a simple approach of saying, this is how I answered your question, and produce something that a human could understand about how the question was answered.
But this seems to be what so many people are looking for right now, is that we have agents making decisions and executing tasks. And let's just say that we had an agent who is like a like your friend in London that can give you recommendations that you've never been to the city, and like, hey, where can I drink craft beer? Well, here's an example of, well, if I asked, where can I drink craft beer? And then if I asked, well, what's a pub that serves craft beer? And if I get a different answer and I don't like that answer, now we have the capability to actually go through and say, why did that seemingly similar question give us different responses? And this opens up the door to being able to understand why you get the outcomes that we got. Were these the outcomes we got? Sometimes, we have to be honest with ourselves. Language is a communication tool for humans, and now we're communicating with a technology. Whereas if I ask Mark those two questions, where can we drink craft beer, and what is there a pub that serves craft beer? I suspect he would have responded the same way in each situation, because there's a lot of connotation there. There's a lot of assumptions, because if we were in the same place at the same time, there would be the connotation of, well, he's probably asking somewhere that's nearby right now. So what's somewhere nearby? There's all this that's understood in the connotation and the context of the situation. Well, a language model has none of that. It doesn't think that way, because it's a language model. It's just a lot of ones and zeros and other numbers. It's just a piece of technology. So it will interpret the language based on the cold, hard, contextual setting that we, the human, give the language model. So what I'm getting at is, well, should I say it? Should I just be the blunt way of saying it? Should I do it? If you ask a stupid question, you might get a stupid response. There, I said it. I did it. I know. Please retreat to sufficient safe spaces if you have one. But it can happen. if you don't ask a well-formed question, or if you ask a question with a lot of contextual ambiguity, should we be surprised that we don't necessarily get the answer that we were thinking? For instance, if I was with Mark right now and he's in the UK and I somehow go over there and I say, hey, where's a pub that serves craft beer? And, he answers, somewhere down the street. And I go, no, I wanted one in London. Well, why would he assume that? That would be odd for him to assume. So it wouldn't be his fault that he didn't answer the question the way I wanted, because I didn't ask the question with the correct amount of context to provide the right answer. And that's what we're really getting at here. That's the promise of this technology. And that's the promise of neuro-symbolic AI, is this semantic granularity, this accuracy, this precision, to being able to understand these requests in a new way, so that now we can look back at these requests and say, hey, the user wasn't happy with the response of this agent. And we trace back and go, well, maybe the agent didn't do such a bad job, because most people would have interpreted the question the same way. And then you start having to understand, well, do we have to guide the user in a different way because of this wasn't what they wanted? Now we have that explainability, that traceability, where we can go through every step of the process and being able to understand all those potential decisions, all those potential concepts that were related. For instance, even when we asked the question, where can I drink craft beer? All the concepts that we found, that's way more concepts than I would have ever thought of. Like, I wouldn't have thought, like, oh, yeah, you're right. Should we look for, events and festivals and beer gardens and that sort of thing? I wouldn't have thought of all those myself, but those were all valid options.